Hello, everybody. I'm Aaron. I'm the simulation engineer at the KSE Group. We are formerly known as KSE Process Technology. And as you already see in the slide, we are like an animal nutrition factory design company. So we make factories for pet food, premix, all this kind of things. And I'm going to tell you something about efficient simulation within our company for all kind of cases, and I will especially highlight one case. So as a company, as KSE, we are thinking out of the box, but I first want to show you what's in our box. So what is in this presentation. I will first quickly give you a presentation outline. So I give you a short company background and why we use simulation and how we use it. Then I'll give some information about the system we do simulate in the use case. I will give you more information about the use case, the methodology, and the future directions we want to go, and other cases where we use simulation. So KSE, what are we? We are a family company and we started like 50 years ago. And we manufacture all different kind of machinery for the animal nutrition field. So to give you an idea, I showed you 3 examples. At the top, you see like the very small beginning. It's like a stationary micro weigher. Also a small one is standing over here, but in reality, they are way bigger. And for example, we also have movable weighers, as you can see at the right. And at the bottom, you see the whole system. It's called automated container transfer. I will call it ACT in this presentation. And there is also the presentation use case about. So we are a company, we not only manufacture the machinery, we also automate the factory, design it, and do the aftercare. So we really help the customer during the whole process. And therefore, simulation can be very helpful. And I will show you in the next slides. So first of all, what do we make? We make small factories, as you show at the left. So these are factories without a lot of machines, silos, etc. But we also make very complex factories with a lot of silos, a lot of machines, trucks coming in, out, everything. So we really do this whole span from very simple simulations to very complex simulations. As I already told, we do like everything in the factory. We don't build the building, but everything inside the building can be made by our products or third parties we work together with. So Alpha stands for really the machines we make. Then we have the middle tech where the simulation comes in. We engineer the factory, we make everything, we construct it, etc. And then it's automated by the other department of a company. So our motto really is the factory of the future will have only 2 employees, a man and a dog. The man has to feed the dog and the dog has to keep away the man of the equipment. So in other words, we really want the factory to be completely automated without really having some human labor or the least human labor possible. If we then look at simulation, where does it come in our process? Now, when we design a factory and manufacture it, we always take this timeline. So the first stage, we really define the project. What do we need? What should be the capacity? What is the building requirements? Will there be future growth in the production, etc., etc. We get this all from the client, and then we're going to design it. So we design the process, but also the mechanical part. And those two together come in the process simulation, where we just make a simulation model of the factory at the start to see if we can reach all the requirements in the definition phase, but also if we can expand later, if there will be deadlocks, etc. But more about that will be later. And when we make it, we show it to the customer and we can go further. When everything is agreed in the second stage, we're going to engineer it, construct it, and do the implementation. And after it's implemented, we also have some care, and therefore simulation can come in again. So you can optimize the factory by simulation, as we already saw in a few cases presented before. And we can do so other data analysis about these factories and improve it again by simulation. So we really use simulation in 2 parts of the process, where the use case in this presentation will be mostly about the simulation at the start of the progress. So why do we use AnyLogic or simulation? Now, first of all, we use simulation because it's quite stochastic, complex. We can't use simple calculations, which makes it quite hard to do, and therefore simulation models are the best. So we, for example, have varying routes, dosing time, waiting time depends on the situation, dosing times are stochastic, etc., etc. But most importantly, we also want a great visual representation, not only for us as company, but also for the client. When we show them the factory we are going to build, we can convince them to really buy it from us, and they also understand better what we are doing. And of course, when we test everything at the start, which you see in the graph on the right, the impact will be higher. So we will higher influence at the start, because now we can, what already Jacob and told me in the previous presentation, when you do it at the start, the cost will be way lower. We can just add one unit, we can delete one unit, we can add an extra layer, etc., etc. When we do this at the end, the cost will be very, very high, and it will be hard to make changes. So in the model, we can already analyze the potential bottlenecks, the utilization, the waiting time, the throughput. We can see everything before the machine is standing there, or before all the machines are standing there. Then I will tell you something more about the use case. So I want to tell you more about the ACT we are selling. This is really a whole system of containers moving to a factory. So here in the visual, you can see it. It's a container really moving to the factory, discharging, taking up stuff. It can be very small, as you see in the beginning of the video. If we look further, you can see it can expand and can be very big and complex. The advantages of this approach, instead of the old pneumatic tubes, is that you can do everything contamination free. For every product, you can use a different container, which you can clean afterwards. Also, you can expand very easily by just adding some units. To give you an impression how this looks in real life, so it's quite big. It looked maybe a bit small, but the machines are very big, that you can see in this video. So you see like how big it is, how it works. So this is the factory we simulate, and then in real life, it will look like this. You see all kind of different units, like the elevators, which moving them up, conveyors where they are moved on, holes where they can discharge their container, and parts where they can fill it. Then we have, for example, this to discharge the container. So then you have an idea about the system. Then we, of course, sell this system quite a lot. A lot of customers want this, and we cannot every time completely from scratch create a new model. And therefore, we had to create a template which makes it possible to very quickly create different of this kind of systems, but with the same units for different customers. And therefore, we had a few requirements. So it should be robust and usable for multiple customers. We should make it very quick. We cannot make like weeks or months to make the model, because we want to show the customer as quick as possible a preview of their factory. Then, of course, it also needs to be customizable. So we need to change speeds, for example, of conveyors or shuttles or elevators, but we also should be able to adjust dosing times. It should be very user-friendly for our sales consultants. So not only me as simulation engineer, but also other people in our company should be able to use the model without really having simulation knowledge. Of course, what I already said, we have to need a decent visualization of the system. We need to convince the customer with it. So we really need it. And of course, we need to have the most important KPIs to see if the factory is working as we expected. Is the throughput what the customer required or not? Are the waiting times which we can already improve at the start? How did we do that? We have a methodology in where every ACT unit type, for example, an elevator, a shuttle, is a separate AnyLogic agent. We created an Excel file with tunable parameters, which automatically makes the ACT units in the model. We can define the locations of the units as a node. The routing we base on a simple Excel algorithm, and we use like all the different kind of parameters which can be filled in the Excel by people just very easily. to show you which kind of agents that you can find in a model. For example, we have a separate agent for the containers, which has a container number, type, start location, color, but also we have conveyors, which contains of a name, a speed, a location, a specified length, an orientation, and of course a flowchart in it, which defines how it goes. Then again, we have also dosing unit agents, discharging unit agents, and elevators. I won't go too deep in everything, but we have a lot of more agents, and they all act together in the model. So they all have relationships with each other. They act together, and we have to make that in the model, which makes it quite complex. And therefore, we used like different approaches. So I first will tell you the old approach we used. And then we have a current approach, which makes it already easier to make a model, and the future approach, which we are currently constructing. So first of all, how does it look like a flowchart inside an agent? This is, for example, a discharging agent. You can see here we have the parameters which will be filled in by the Excel, and here is how it flows. If we then go to the next slide, I will go into the approaches. So what I already told, to make this ACT very fast in AnyLogic, we had 3 different approaches. In the initial approach, we really created the whole model from scratch, but this will take weeks or months for complex systems. And then the customer is already not interested anymore because they find another party which can do it maybe faster or better. So then in the current approach, we created a model in AnyLogic where you just have to create the floor plan, as shown here in the middle picture, where you just have to put the nodes and the routes, and then you can fill in what has to be there. So a CC is a container conveyor, has to be located at node 15. It has to be 1700 millimeters, and it has to be a rotation of 0. By this, we can create floor plans very fast and also can adjust them very fast. Now in the future method, which I will show you in a preview, we really try to make something like a roller coaster tycoon like Sims, where you just can click and make things. To make this more clear, I will show you the video of it. So you really have a user interface where like somebody which isn't even a simulation expert can do things in. He can choose to create a floor, he can name it, he can say the height, the width, and the length, then he creates automatically the floor. And then you can choose all the different agent types we have, where you want to locate it by a click on the map, the orientation you want, and you create it and it will be located there. Then, for example, we also want the shuttle there. We create a shuttle. We can adjust the length of the shuttle. We can choose the orientation and the speed. And then we can create this unit. In this way, we can really create factories very quick and also have a visualization. You don't really have to have any simulation knowledge. You can just make it. Then when you have the floor plan, the most difficult part comes in, and that's really creating the container flows through your factory. There are millions of routes possible, etc., etc. To really do this, in the first, like the old approach, we created the containers manually in AnyLogic, and for every possible flow, we created like a unique flow chart. We saw by Gusto that this will take very much time and also takes a lot of calculation for your model. So therefore, we created a more simple algorithm in Excel, where you just, what you see in the middle picture, where you just put in the start point of your route, the end point by the ID of your unit, the resources you used, and eventually buffers, etc., where he can move to. Then you just make a loop in AnyLogic, he checks if it's free, and if it's free, he takes the route. All of it is done in Excel, so somebody without simulation knowledge can make it quite fast and simple. Only for quite complex factories with like thousands of routes, making this Excel file will still be time consuming. Therefore, in the future, we want to connect it with the container transport program algorithm we use in real factories to really use this and test this. For now, in the tool, we have already created an option to just create containers by click. And therefore, again, I want to show you some kind of preview. So you can really click where you want it. First, go to the user interface, click where you want it, select the unit you want to place it on. You click which color you want to be the container. You say it's, for example, cat food. You say it will be located there. You create it, and the container will be created in there. In this way, again, a simulation engineer can make it, but also a sales consultant without any knowledge. So that's step 2. Then when you have the floor plan and the routing, the next step, of course, is to run the simulation model. In the previous and the old methods, we really created the chart and everything from scratch. So we again have to think about, do we need these KPIs? Then we have to code something in AnyLogic, make some charts, etc. We have to do that same again, and that will be time consuming. Therefore, in the current approach, everything is measured inside the agents you create by the Excel file. It's modeled directly and started with a visualization, which is quite decent. And we show the standard KPIs. So for example, now I'm going to show you a model which we made within, I think, 4 to 6 hours, maybe less, with the template. So when you don't have a template, this will take, I think it's still not very complex, so it will take a few days, but you can already see that it's quite a lot faster. So here, for example, we have a factory. So you see the containers moving at the top, where they be filled, and they will move it to the mixer, where it will be picked up by this container and moved to some discharge units. Making this with the template was quite fast, few hours, and it was made. Even the results, etc., were shown immediately. So then when we continue, in the future, we want some artificial intelligence tools inside the model to improve things. You can think of silo allocation, but also maybe waiting times. How can we improve this? But this is really a step for the future where we are not at the moment. Then, when we have the model made in a day or in 2 days for a new factory, we of course have a lot of KPIs we have to analyze. So again, we can see, for example, what is the utilization of different units. You can see it in the picture below. So you see, for example, the CCVD. 1 is utilization 20% of the time. When we know this on forehand, we maybe can think, we don't need 2 of this. We only need 1. We see it quite fast. It's not necessary. We just put 1 away. We can also see potential bottlenecks. So we can see, for example, that a waiting time for 1 dosing unit is like hours and 1 is almost not used. Maybe we can change something in the route, do things and fasten it up. We can also see potential deadlocks, which can occur because some containers are blocking each other. Then we see our routing is not correct. We have to change something, and we know it before installing it at the customer. Then, of course, what was shown in the first slide at the requirements, we have a customer which asks for a certain throughput. When we see in a model that we reach this throughput or even higher, then it's okay. But if we see we make too low of throughput, then we maybe need to adjust something, add something to reach this. And we also can already test future scenarios or production increasements. And at least we can also see, for example, the energy consumption. When we know all these things at the starting of building the factory, again, this picture comes in. We can change things very easily without having a lot of cost. It will be fixed very quickly without a lot of adjustments. So that's very good, and that's why we do this. Then besides this tool, which we particularly use for the ACT, we also have like other tools inside KSE. For example, our bulk transporters, which are transporters which transport way bigger amounts of weight. We also created like a tool for this, like Rollercoaster Tycoon, where you can simply adjust things, add things, create things. This thing to make this model was way easier than the ECT because of this hasn't a container moving through it, but it are just moving parts, which are quite easy to simulate. Again, a sales consultant can go with this model to, for example, a customer and make together with the customer this particular model or system. And he can look and he can say, yeah, this is what I expected. This is not what I expected. Maybe you can change this, maybe we can change that. And you can really do it real time with the customer. Then, of course, we also have like other use cases where we use AnyLogic simulations tools, for example, for optimization of current factories, which I already showed in the project route, silo allocation problems where you can, for example, use machine learning and simulation to allocate different silos and materials to different weighers. And in the future, we are really willing to go to really digital twins where we connect the model with data from the database of the customer and really make the model real time and make some production adjustments, etc. with the model. So that was really my presentation. So now we'll look at the questions, if there are any questions. I see one question. Aaron, how long did it take for you to complete the project? Were there any challenges? When we really look at the ACT and then the current approach, it wasn't really taking a lot of time. I think in total time, I think 2 months for one person. So let's say 300 to 400 hours to really make the template. The future approach, this will be quite a lot more. I think we will have a route path of like 2 to 3 months to make this model. But for example, the bulk simulation model tool, which I showed you in the last slide, that's been made in like 1 or 2 weeks. So it really depends on the complexity of the situation. But it wasn't really like a year of effort, only a few weeks to months to really make the template. Was it worth to design the template over simply teaching your client to use AnyLogic over? Yeah, I think it was really worth it because the template really helps. And for example, we go to maybe 5 to 10 clients a week as a company. To teach all those clients AnyLogic and make the model will take years. So it will really save a lot of time to really do it by this template. And also the template can be used for years since it's really a one-time effort and now it works. You only have to change parameters. Great PowerPoint. What's your definition of a digital twin? How do you propose to use it? A digital twin, we really see it as a factory which is already built. We create exactly the same factory in AnyLogic. We also use the same times as they do. So for example, they have a dosing time of 200 seconds. We took it from the database and loaded it in a model. And we really make it that. We want to use it for production planning. So they see they have 200 orders for that day. Then we're going to look at the perfect sequence of those orders where the waiting time will be the lowest. And this can be continuously changed because they can get another order from another customer every day. And therefore you really have to have a model which can quickly react on the real situation and how it can go further. Could you please provide something? So can you please provide examples when the client expected something different? What adjustments you had to do? Yes, of course. For example, a company has some building requirements. They cannot build like a factory of 20 meters. And so we have to build everything in a small area. In a small area, we put a CS, a shuttle, 2 shuttles or 3 shuttles and a CC. Then during the making the simulation model, the customer says, yeah, I don't think that's the correct option. I think because our customer is king, so we do exactly what he told us. So he said, and maybe put that shuttle at the other side and make the routing like this. And we do that, of course, for the customer. And then he tells me, and then there's the simulation can show if he's right or we are right. So it can be, we are not discussing it anymore. We're just showing the results and then we know, your customer, you were right. Your solution is better, or we can say our solution is better. And in this way, we can really interact with the customer, make changes, communicate faster results, and go back to other solutions. Yes. Then Deng Deng asks, how long does it take to build your agent specific to your company? Yeah, but it was the same answer as the previous question or a few questions before. Making this model really only took like 2 to 3 months, I think, to really make it from scratch. So create everything. The most difficult part really was the routing algorithm, because yeah, it's quite difficult to make a routing correct as you expect it in real life. And what I already told, to make everything in a separated flowchart, all possible routes, or use if statements. If it's that, then that, then your model will be very, very huge. And therefore, we really created that routing algorithm, and that really took a lot of time to make. But really creating the floor plans, etc., constructing that model only took 1 to 2 weeks, and then the routing algorithm 1 to 2 months, and then finishing everything in a half month or something. It wasn't really like a long-term project. It was quite short. But I think the future approach will take a long time, and we are continuously improving it. So it will be a never-ending story, I think. So that were the questions.
Yeah, Aaron, it looks like all of the questions now, but maybe we have one more about the future approach you described. Why did you not immediately implement this?
Yes, good question. We want to start we want to build it in blocks. So we don't want to start with a very complex, requirement list with a lot of things. We want to show that it's working, that our IDs are working with as minimal effort as possible. And therefore, we just created like the current approach, where we showed, for example, the management at the company that we can really make it, but we need some time. And this one is already helping the sales consultants and or simulation engineers really a lot. But in the future, we really want to have only one simulation engineer, which only works on the development of the model, and the sales consultants work with the model. But to do that, it will take months or years, and we now want to make it in small steps to the end product.